Here is the transformation foldable. I just cut around the outside, cut down the sides, I cut off the top and the bottom, and then you're just going to fold the doors into the middle. You can cut each one of these doors if you want to. Vertical shift up. Here's our main function, x squared. A vertical shift up means you're talking about the y-axis. And so here I'm wanting to shift up 2. That's on the y-axis. So that means x, and I would be adding 2 to my y value. All my y values are being added by 2. 0 plus 2 is 2. Here I have y is 1. So 1 plus 2 is 3. Same thing on this side. 1 plus 2 is 3. And I can see my parabola here. This would be at 4. So 4 plus 3 would be 7. I'm not going to put that one on here, but here is the parabola shifted vertically 2 units. Vertically shifting down, we see minus k, and I'm shifting down by 1. Here's my square root. The square root function, it's not with the x, it's on the outside, the k value, so that means that all of my y values will be shifted down 1. So we have 0 for y, that means I'm going to be shifted down to 1. Here is another point I'm picking, it's at 1, so it'll be shifted down to 0. And another point right here, this is at 2, and I'm shifting it down 1. There is the square root function being shifted down 1. Horizontally shifting has to do with the x. That is the x-axis. Here I would like to shift all of my units. Now be careful here because of the minus sign. I'm not going to -2, but I'm actually shifting to +2. So all of my x's I'll be adding 2. Here is an x. It's at 0, so I'm going to add 2. Here is an x at 1. I'm going to add 2. 1, 2. There's 1 right here. I'm going to add 2. 1, 2. Starting to see that V shape. Let's go for one more. Let's go here. I pick this point and shift 2. 1, 2. 1, 2. I shifted 2 in the positive direction. I added 2 to all my x values. Same thing with shifting left. That means I'm going to be subtracting 2, not adding 2, but subtracting 2. All of my x values will be subtracted by 2. Subtract 2 from my x over 2. I take this point, move it over 2, 1, 2. I'm going to take this, move it over 2, 1, 2. And one more. Let's go with this one. 1, 2. And 1, 2. I can see that my parabola has been shifted to the left 2 units. I subtracted 2 from all my x values. We have been working on vertical and horizontal shifts that you should be familiar with. And now we're moving on to other types of transformations like reflections, stretches, shrinks. Okay. Reflecting over the x-axis. To reflect over the x-axis, that means you are going to negate all your y values. I'm reflecting over the x-axis, therefore I'm changing the sign on all my y values. This would still be the same. If y is 1, then -1 will be in the reflection. If y is 2, then -2 would be in the reflection. I have just reflected over the x-axis. Can you take a guess what we're going to do to reflect over the y-axis? That means that I would have to negate all the x terms. That means all my x's will be negated to reflect over the y-axis. This one's going to stay the same. Here I have that x is 1, so negative 1 for x. X is 4, so negative 4 would be in the reflection. This time we reflected over the y-axis. To reflect over the x-axis, we negate all of the y values. To reflect over the y-axis, we negate all of the x values. Vertical stretch, vertical, has to do with the y-axis, has to do with the y variable then. Here is my function, the absolute value of x. Here it is at the origin. And I am going to vertically stretch this by 2. It's being multiplied to the function, not to the x. The 2 is being multiplied to the function. So that means that we're multiplying to the y value. That means that we would have x, and then we're going to multiply 2 to all of the y values to get a vertical stretch, stretching it out. So I'm going to multiply 2 to all my y values. When x is 0, we have that y is 0, and it's still going to be 0. When x is 1, we have that y is 1, but when I multiply 2 to 1, I get 2. And we'll go for 2. We have 2, 2. So when I multiply 2 to my y value, I get 4. We have 0, 0. Here is 1 times 2 is 2. And then 2 times 2 is 4. And we can see that it's vertically stretching up. This would also be true on the negative side. The absolute value of negative 1 is 1. And then when I multiply 2 to it, I still get 2. But negative 1 is also at 2. And that would be true for at 2, we would get 4. So here we can see the absolute value has been vertically stretched. It's being stretched, which making it skinnier. It has been vertically stretched by 2. What would a shrink look like then? If this is stretching up, then that would mean a shrink would be going out, going further away from the y-axis. This got closer to the y-axis. A shrink will be laying down more, further away from the y. All right, here's a cubic. We haven't done too many polynomials, but we're getting there. All right, so I have a vertical shrink. That means that you're multiplying to the function, but this time it's a number between 0 and 1. That's a fraction. So a shrink would be when you're multiplying a fraction to the function. So here we see that nothing for x, but I'm multiplying to the function y, 1/4 of my y's. All right, so 0, 0 would still be there. 1/4 all my y's. Well, here's 1. That means at 1/4 would be down here. It's laying down, and that would be true as well over here. It would be laying down more. You can make a table of values for all of these. Let's go with all right, x is 2. 2 cubed is 8. And now when I multiply that by 1/4, we get 2. And that would be true for negative 2 as well. Negative 2, we get negative 8. And then when I quarter that, I get negative 2. And so a vertical shrink means it's been flattened out a little bit. It's gone out further away from the y-axis. It's been shrunk down. A vertical shrink. It was at 1 and it shrunk down to 1/4. It was at 8 and it shrunk down to 2. Vertical shrink versus a vertical stretch. Those are pretty straightforward. Unfortunately, as it is when you have the shift on the x-axis, you always have to think of the opposite for a shift left and right. That's going to be true for the stretch as well. We're talking about horizontal. We're talking about the x, which means you've kind of got to think about it the opposite. All right. So we're looking for a horizontal stretch. We want a horizontal stretch, which is really the same thing as a vertical shrink. These are the same, as well as these two. All right, so here we want to do a half x. When I substitute that in, that is, you are squaring that. You'd have parentheses here, and you'd put a half x in there, and you would get a half times a half is 1/4 x squared. So a horizontal stretch is when you have a fraction and you're multiplying it to the x. Here you were multiplying it to the y value. F of x means y. So really it's a times y. You're multiplying your a to the y value. Here you're multiplying your a directly to the x. When x is 1, we get 1 times 1/4 is 1/4. Coming down here. And that would be true for -1 as well. And when we have x is 2, we get 2 squared is 4. And then 1/4 of 4 would be 1. So at 2, it's 1. At -2, that would also be true. We can see here that a horizontal stretch is the same thing as a vertical shrink. So the horizontal stretch is being stretched out this way, and you're multiplying it directly to the x. Directly to the x versus to the y. A horizontal shrink is when a is greater than 1. And that means we're going to be multiplying to the x. So 0, 0, when x is 1. We get 1 times 4 is 4, and the absolute value of 4 is 4. That would be true for -1 as well. -1 times 4 is -4, and the absolute value of -4 is 4. And so we can see here that we've had a horizontal shrink. Horizontal, it's going this way, and it has shrunk. So we have a horizontal stretch and a horizontal